Hello and welcome back. Okay, so we're continuing on from our last video where we were calculating the interest rate as a part of compound interest problems. Okay, and this is just going to be a little bit of a harder example that we need to take more into consideration when we're solving it. Okay, so here's the example. Calculate the interest rate per annum that would allow $6,500 to accumulate to $8,000 in 6 years if interest is compounded biannually. Okay. Now, what I want you to highlight immediately using a different coloured pen is that now instead of saying compounded annually, it's compounded biannually. Okay? So remember, biannually means that twice per year it is compounded. Okay? So this is every 6 months. Okay? Not for the full year. So that's going to change up everything that we do in this question in terms of what values we substitute. It's very much the same process, we just need to do some extra steps. Okay? So, continue on with the highlighting all of the important parts. What we need to do is we need to look at the fact that the question tells us that we are calculating the interest rate per annum for the whole year, okay? That would allow $6,500, so that's how much we started off with, to accumulate to $8,000, okay? So that is our final amount, okay, in 6 years, and that is our time frame, okay, along with the compounded biannually, okay? Now, it says that it's compounded biannually, so we know straight away that we're going to be using the compound interest formula. A is equal to P outside of 1 plus R all to the power of N. Okay, so let's have a look about how we would do this sort of question. Okay, so over on the left-hand side here, what we're going to be doing is finding all of our values. Okay, so if we go through the question, we know our final amount is $8,000. That's what everything is accumulating to with interest. It is growing. So it is $8,000. Okay, for this question, okay, right, our principal amount, the amount that we start off with, is $6,500. We don't know the value of R. Okay, however, what we can do is we can look at what our interest rate, what our compounding periods is going to be. So if we look at N, we know it is in there for 6 years, okay? And it's compounded twice per year. So that means that if our N is equal to 6 years, it's compounded twice per year. 6 times 2, the amount of compounding periods we have is then 12, okay? So we have our values. Let's substitute everything into the formula, okay? Our A is equal to 8,000, so we replace A with 8,000, okay? Our principal, our starting amount, is 6,500 multiplied by 1 plus our interest rate. We don't know what the interest rate is, so we're just going to write an R, all to the power of our number of compounding periods, which is 12. Okay? So, from here on out, what we need to do is we need to try and get this inside the bracket by itself. Okay? We will eventually try and get R by itself, but we need to remove the stuff from the outside first. Okay? So, the number that we're going to remove first is the one out the front of the bracket, okay? Now, you'll notice in between this and the bracket there's a time sign, okay? And the opposite of times is to divide. So, the opposite operation is divide. We divide 6,500. Oh, sorry. Okay? And what we do to one side, we must do to the other. 6,500, okay? Now, you'll notice that you have 6,500 divided by 6,500, okay? So, we can cancel these out, leaving us with, on the right-hand side, only this bracket to the power here. 1 plus R, all to the power of 12. Okay? Now, on the left-hand side, what we can do is we can enter this onto the calculator here and obtain a fraction. So 8,000 divided by 6,500 will get us a fraction of 16 over 13. Now, the only reason I do this is because it's easier to work with less numbers here. Okay? Now, we're nearly there. We're nearly to our answer already. You'll notice here we have to unlock this bracket, okay? And to unlock that bracket, we need to get rid of the power. Like I've said before, the opposite of a power 12 is the 12th root, okay, of both sides, okay? We're doing the opposite operation, okay? So, to combat that power 12, I'm going to take the 12th root of both sides, okay? And what I do to one side, I have to do to the other. Okay? I take the 12th root of both sides. What's going to happen then is my power and my square root will cancel on my right hand side, leaving me with 1 plus R is equal to the 12th root of 16 over 13. Okay? Now what I'm going to do, just to make this a little bit easier while I'm solving this, I'm going to switch the sides of the equation, just like what I have before. Okay? So I'm going to write the 1 plus r on the left-hand side is equal to the 12th root of 16 over 13 on the right-hand side. Okay, the 12th root. Okay? Now, we're nearly there. We've nearly got the r by itself. You'll notice I haven't simplified this root here. Okay? And it's just to make it easier in the final step, I just do everything in one go. So, let's continue on. Out the front of this 1 is a plus. Okay? We're nearly there to get the r by itself. So what I'm going to do is I'm going to do the opposite of plus. I'm going to minus 1. Okay? And what I do to one side, I must do to both. Alright? Minus 1. That will cancel, leaving me with r is equal to the 12th root of 16 over 13 minus 1. I cannot stress enough, well, let me move this up so you can see, cannot stress enough that minus 1 is not underneath that square root. Okay? So, let's think about how we enter this onto a calculator. In fact, if you'd like to, you can pause here and figure out the answer to the question if you'd like. See how you go. There's a little trick at the end. Now, for this particular question, just like before, I'm going to take the shift and press the X to the little box, okay, the power symbol to get that up. And I'm going to enter in the 12th root of 16 over 13, and I exit completely out of the square root sign, and I go minus 1. And that will bring up this horrible decimal there. Okay, so we end up with 0.017453 ... which continues on forever. Now remember, I want this as a percentage. Okay, so to make this a percentage, I'm going to multiply this step by 100%. Okay, I'm going to multiply this. So I take this number, multiply by 100, okay, and add a percentage sign. Once I've done that, okay, my decimal will become 1.745 ... Okay? Now, here's the thing. Here's what we need to be really careful with. Notice that I haven't rounded anything yet, okay? I'm still going with everything as a decimal. I'm just dotting everything out, okay? You'll notice that this interest rate is not for the entire year, okay? This interest rate is actually for every 6 months, okay? So for this to accommodate, this interest rate to accommodate the entire year, okay, we have 2 compounding periods in a year, so we have to double this interest rate to make sure that we get the full interest rate per annum. So we have to actually multiply this by 2. Okay? Now I haven't rounded specifically for this reason, okay, to make sure that my answer is accurate. Alright, so if I multiply this here by 2, okay, what we end up with is 3.4907 ... And that is actually now per annum. Okay? So we're nearly finished. Let's just make this a nice percentage and round this to 2 decimal places. Okay? So, I'm going to round to 2 decimal places. After my second decimal place, I draw a line. It's 0, so the 9 is going to remain the same. So that means we end up with 3.49% per annum, correct to 2 decimal places. Okay? And this here is our answer. We are finished. The reason why we have to make this per annum is because it asks us up here in the question to calculate the interest rate per annum, per year. But what happens here is we are actually only compounding biannually, so we have to take that into account. And that's why these questions are a little bit harder. Okay? So because it's biannually, we multiply by 2. If it was monthly, we would multiply by 12. If it was weekly, we would multiply by 52. Okay? I hope this helps. Alright? Thank you very much.